Hello guys, I hope you're all well. Welcome back to my analysis arc, and this is the grade 10 revision from Maths paper 2. So now just to warn you before this video starts, this video is going to be a very long video. It's going to be very long-winded because this is a revision video and I'm trying to cover as many topics as I can to prepare you for paper 2. Now I cannot cut this video into different parts, to part 1, part 2, part 3, because it's a very exhausting exercise for me to upload a part series revision video on YouTube, as it takes more time for me. So here we go guys. This cover, as you see it here, I would like to send my apologies up front. This cover, as you see it here, it's written Maths paper 1 there, Maths paper 1. It's because by the time I made this cover, it was actually meant for a revision video for paper 1. Unfortunately, due to some events that are, long story short, I was not able to upload the video. But then here is video 2 guys. If you are seeing this video, it means I succeeded. Also, I would like to let you be aware that what I've realized is that as I'm writing on my videos, the longer my videos become, as I'm writing, the writing will somehow get to disappear. And I don't know why. Is it the recording, or is it the writing tool or the software that I'm using to write on? Maybe it is the problem. I don't know about that. So please pardon me on that one if it ever happens. In fact, it will happen. So when it happens, please pardon me on that one. So now let's start with this video. In this video, also for paper 2 now, what I know is that for grade 10, Euclidean Geometry and Trigonometry, they're usually worth a lot of marks. So you need to master them for you to succeed in paper 2. So if you can kill Euclid and Trig, you are guaranteed above 50% for the exam on those two topics because they are worth a lot. So please make sure you master them. When it comes now to analytical geometry and what else, measurements and stats, those ones, yes, they are with marks too, but they are easy to master, those ones. Hence, I'm emphasizing for you to master Trig and Euclid because they are just the tricky parts there in the exam. Now, let's start with analytical geometry. Also, I just keep on saying also remember. Also, I don't have stats in this video because preparing for a stats lesson takes a different, how do I say this? Preparing for a stats video, it takes a real effort to prepare it. It needs a separate video on its own for me to do a stats revision, as in opposed to these topics that I'm doing now. So please pardon me if there's no stats in this revision video. So I think I got everything out of the way. Now we can move on, guys. So for any malfunctioning in this video, please pardon me, guys. If I ever make a mistake, please forgive me, guys. I'm sure I will make a lot of mistakes in this video because this will be a very long video and I'm touching on a lot of topics and many things might not go in line. My calculator sometimes keeps on crashing. My software calculator, like this one, it keeps on crashing as I'm using it. I don't know why. Sometimes this system that I'm using might shut down, but bear with me for any technical errors, guys, or any mistakes that I make as I'm explaining to you here, because I have to take a lot of things into consideration. Okay, let's move on. I think I got everything out of the way now. Let's move on, guys. Here is a question paper, a question from the Gauteng November 2018 question paper, and it goes as follows. Let's go straight into it. So here it says in the diagram below you have coordinates P. So whatever you read here, make sure it corresponds with whatever you see on the diagram here. So here it says in the diagram below you have coordinates of P and they are the same, coordinates of Q and they are the same, coordinates of R and they match. Are the vertices of a triangle such that PQ is equals to QR? They're saying PQ is equals to QR. Now that is not shown on the diagram. it is your responsibility to illustrate that on the diagram this way. These two lines are equal. Let me do this properly somehow. Yeah, we all see that, right? And it also says that PQ is parallel to QR. So PQ, not parallel, perpendicular. It's perpendicular to QR. So here's the perpendicular symbol there. Perfect. T is a point on PQ, such that T is the midpoint of PQ. So they're saying this now is the midpoint of this whole line. Now let's illustrate that. It is your responsibility to show yourself that. Boom, boom, right there. It shows now that that is the midpoint. And then what else? S is the point of intersection of RQ and the x-axis. So S, RQ intersects with the x-axis, makes sense. V is a point on the x-axis such that QSV is 121. QSV is 121, V on the x-axis. Okay, QPS is theta, here's QPS being theta. You see that everything that's on the statement now is on the diagram, so we no longer need the statement. We are done with the statement. Now to answer the question, now are you taking into consideration the speed that I'm using now to analyze this and to move on to the question? So it's because you need to be fast on the question paper, guys. When something says 2 marks, you need to spend max 2 minutes on it. Now you need to take into consideration that now you have to read the statements, you have da-da-da, all those things. So let's move on now. It says, find the length of PQ. Now, for you to find the length of PQ, remember now that whenever you are writing a maths paper, you won't be given a formula sheet. Now, if that is the case, you are supposed to remember every formula you need for this paper. So here we know that we have x2 minus x1 all squared plus y2 minus y1 all squared, right? But then to make things easier for you and for the rest of this video, we are going to say now, whenever we have a situation like this one, instead of saying x2s and x1s, we are going to label them the way they appear. We are going to say x at P minus x at Q squared plus y at P minus y at Q all squared. Now, why are we doing that? We are avoiding to label things as y1, y2, x2, x1, and they become confusing at times. But what you need to make sure is that if here you started with xp, here you also need to start with yp. I hope it makes sense. Now let's move on to substitution. For substitution, what we have is that x at p, how much is x at p? That is 1, minus what is x at q? That is 6. We square that plus y at p is 0, y at q is 3, and we square that. And all this is under a square root, remember that. Now for something that is worth 2 marks, you bet that they only want you to substitute and to give us the answer, of course. So now I'll move from this straight to the answer. Now let me punch this on a calculator. I'll pause the video so that we just move on to the answer. So here is the answer I got from my calculator. It says the root of 34. Now because I'm measuring distance, I'm going to say units. If I was given centimeters, I was going to write centimeters there. If meters, I was going to write meters. Now, the question said I should leave my answer in a surd form now, which means here my answer is just going to be the root of 34 units. Don't forget this part that says units, right? Because you want to show that you're talking about length. Now, next question. 2.1.2, it says give us the gradient of PQ. Now, my formula for gradient of PQ is going to be y at P minus y at Q all over x at P minus x at Q. You can use that formula you understand of y2 minus y1, x2 minus x1, if that fits you well. Okay, so moving on, now here we substitute. I have gradient of PQ is equals to, remember if you started with y at P, you also have to start with x at P here. I hope it makes sense. They need to match. Now here I'll have to substitute this one right there, and I also have this one right there. What is y at P now? Y at P is 0. What is y at Q? That is 3. What is x at P? That is 1. x at q, that is 6. Now, how much do I get? For the numerator, I get -3. For the denominator, I get -5. Now, the values of this fraction, they're in the simplest form. But I have two negative signs. I cannot have two negative signs. So this becomes 3/5 because negative and negative, they divide out to become positive. So now my answer there is going to be what? My answer there, boom, boom, boom. For the gradient, I'm going to have 3/5. All set? Remember, you will need to show all the steps. Now, let me clear this area so that I can calculate the coordinates of that. So, question 2.1.3, it says, they need you to find coordinates of t. Now, when you talk about coordinates of t, we're talking about what? It was mentioned in the statement somewhere here. Let me highlight it for you. It was mentioned in the statement. Oh, this is a very huge highlight. Oops, oops, oops. It was mentioned in the statement that t is the midpoint of PQ. So t is a midpoint. We are working with a midpoint here. Now, what does that mean? It means now, let me choose a perfect color. Is this right? Perfect. Now, it means now, for us to find coordinates of the midpoint, the formula usually says you need to find the x values, add them together, divide by 2, and take the y values, add them together, divide by 2 for you to find the coordinates of the midpoint, right? So, but then this way, hence I'm saying, it might confuse you and you might end up making mistakes. So what you are going to do for me is that you're going to say, let me choose a color here. You're going to say your x coordinated p plus your x coordinated q, all that divided by 2, and your y coordinate is going to be your y coordinated p plus your y coordinated q, all that divided by 2, so that you don't make a mistake. Now, these are coordinates of what? These are coordinates of the midpoint. What is the midpoint for us in this case? Our midpoint is t. So I'm going to write coordinates of t there. So then I'll go to my substitution. X at p, it's how much? That is 1 plus what is x at q? That is 6. All that divided by 2. My y values, what is y at p? My y at p, it's 0. What is my y at q? That is 3. I'll divide that by 2. And then now my coordinates at t are going to be what? 7/2 and 3/2. Now, I might not know how do they want these things. So let me put them in mixed fractions also. This as a mixed fraction, it becomes 3 and 1/2. This as a mixed fraction becomes 1 and 1/2 this way. So there I have my coordinates of t, and should be as easy as that. How many marks was that? This was 2 marks. So please spend 2 minutes max on this question. Now, the next question says they need us to find the area of QTR, and that's a triangle. Now let me clear the area and rewrite that thing properly for us. So for the area of the triangle QTR, what do we need then? There we need to find the sides of this triangle, and also the base and the height. So before we start with the formula, okay, let's start with the formula. The formula for area of a rectangle, it says area is equals to half base height, right? And now, sometimes the confusion can come with you determining which one is the base, which one is the height. But then when you have a right angle triangle, it's so easy. So for a right angle triangle, you have the base, you have the height, you have the hypotenuse. So this side that is opposite to a 90 degrees, that is the hypotenuse, right? And any of this side can be the height and this one can be the base. But the hypotenuse cannot be the base and it cannot be the height. I hope that's fair. So now, where the triangle is facing any side that is opposite to the 90 degrees, that is the hypotenuse. And the hypotenuse cannot be the base and cannot be the height. So which leaves the other sides now for them to be the bases and the heights, whichever way you figure them out. So now let's go to our diagram. We have this shape now they want to talk to us about. Let me remove this. Oops. Let me fix that. Yeah. We have this shape here. Let me find a way to erase this, guys. Yeah, there we go. So we have this shape here. Boom, boom, boom. This side from the triangle QTR, this side is opposite to the 90 degrees, which means now this side is the hypotenuse. Now, which leaves this side and this side as my bases and my height, right? So I'll call this side the base and I'll call this one the height. Even if you switch them around, you'd still get the same answer. Now, do I know the distance of those heights? Yes. Let me go to my substitution now. A is equals to half. I need to find my base. So I said this is my base, this distance here, right? From this area to that area. I hope that's fine, right? So since TQ is equals to OT and T is the midpoint of PQ, it means TQ is half of PQ. Now, do I have PQ? Yes, I have PQ. I calculated PQ in the first question. We said PQ was root 34. So now here I'm going to write root 34 because that's my value for that. So the root of 34 over 2 is the distance for my base TQ. Makes sense? Remember we said PQ is the distance from here up until there, right? And half of that distance is TQ. So now if I have the whole distance, from here up until there, then TQ it's half of that distance. Hence I said the whole distance divided by 2, that's the distance of my base right there. Hope that's fine. Now moving on, we multiplied it with the height. Now which one here is the height? Starting from here up until there, that can only be the height because this is the base and this one here, TR, it's the hypotenuse. So QR, do I have the distance for that? Yes. Look at these red arrows. Not arrows, but look at these red marks that we put there. These red marks are there to show us, as we said in the beginning, that the distance of PQ is the same as the distance of QR. So now if I have PQ, it means I have QR. So here, my value for PQ, how much was PQ? PQ was root 34 units. So which means this one is also root 34 units, right? So now my area is equals to how much? You just have to substitute here and give me the answer. Why? Because here you have 3 marks, right? So formula substitution answer. You don't have to do many things here. Now what is the answer for that one? So the amount I get for this one, it's 17 over 2. What's happening? Let me fix that. Where were we? Right here. Yeah. 17 over 2. And now what is 17 over 2? Press SD. That is the same as 8.5. So that is 17 over 2. Area is calculated in square units. Or area is equals to, we said that is how much? 8,5. So I have 8,5 square units. Now in an exam like this one, whereby it was written then, they never said you should give your area in which units. So that's why I'm writing it both ways, as a fraction and as a decimal, to keep myself safe. You see that? Now the next question, it says the size of theta with reasons. Now that's nice. Find the size of theta. Find the size of theta. That's 2.2.2, and this question is worth 3 marks. Now for a question like this, now this is This is interesting. There are people who might see it and there are those who might be struggling. I hope as I'm solving these questions, you are pausing the video and attempting them on your own first to see if you can solve them. Okay. So when we are looking at theta, let me use a different color here. Let's see how it goes. Here is theta. Now, this theta only relates with what? It relates with this angle and it relates with that angle. Now, what's the relationship? Do they have these three angles? We know that this angle is the exterior angle of the triangle here. Here's the triangle. Boom, boom, boom. This triangle right there. So this angle here is the exterior angle of this one and this one, right? Now let's work with that. Now that we know that, let's work with that. What do I know? I know that my 121 degrees is equals to the 90 degrees plus the theta, right? What is the reason for that? It's because this is an exterior angle of a triangle. Exterior angle of a triangle, right? I know that when I have an exterior angle, it's equals to the sum of the opposite angles in a triangle, right? So now here 121. Now I solve this as a simple algebraic problem. Solving for theta here, I'm going to say theta is equals to this 121 degrees minus this 90 degrees as I transpose the 90 degrees to the other side. Now theta will be equals to, this will give me how much here? 31 degrees. 31 degrees right there. So there is theta for 31 degrees. Hope it works fine, right? Now moving on to the next question. The next question says find the coordinates of S. Now that's nice. So here to find coordinates of S. Now that's interesting. Oh, I forgot this angle here. That angle we said it's how much? Oops, I forgot. Oh, it was 31 degrees. Yeah. Sorry, it was 31 degrees. There we go. Oops. Crashed. Where were we? Right here. See, told you about technical errors. 31 degrees right there. So now how do we find the coordinates of S? So coordinates of S, there is one thing we know about coordinates of S. We have X and Y. The first one is X, the second one is Y. But then this is on the x-intercept, which means coordinates of y, there we have 0, right? So perfect. I hope it makes sense now. So also one more thing that I know, there are many ways to solve this thing, and I know you can see them, but I'll just do one of those ways just to save time. So here I have a triangle right there, boom, boom, boom. Right there, perfect. I have this triangle. I know that this triangle is a right angle, right? I have this angle, which is 31 degrees, and I have the side here, which was how much? How much was that? Let's see. That was root 34 units. Root 34 units. Now, if I have this angle and I have this side, I only need to find the distance here for me to find the x value. Now, what does that imply? I can use a trig ratio. Nothing forbids me from doing that. So I'll just say here, this is the hypotenuse. Remember this arrow, we said the side opposite is the hypotenuse. So this is the r, let's call this r. And this, because it's next to this angle, it's called the adjacent. The adjacent is x. So let's say that now the cosine of 31 degrees is equals to the root 34 over the side PS, right? Now I can just solve for PS here. For me to solve for PS, I'm going to multiply this side by PS, and I'm also going to multiply this side by PS, right? So now I have PS multiplied by the cosine of 31 degrees, that being equals to root 34, right? So if I divide this side by the cosine of 31 degrees and also divide this side by the cosine of 31 degrees, this will cancel that, and I'll be left with PS this side, right? Now, I use a calculator to solve for this one, and it gives me 6,80. All set. 6,80. Boom, boom, boom. So there we have 6,80 units. Now, that means what now? That means my x component in this case, it is 6,8. 6,8. That's my x component. Now, my coordinates of S, they become, we said what is the x component? 6,80, and the y value is 0 there. So those are coordinates of S in that case, right? Hope that's proper. And then it says, determine with reasons the gradient of the line through T and the midpoint of TR. We can't even see here, so let's get an eraser quick. So I tried to erase as much as I can there. Let's see the question again. Determine with reasons the gradient of the line through T and the midpoint of PR. Where's PR? There it is. There it is. Let's use this blue line. Through T and the midpoint of PR right there. Oh, yes. Yes, of course. I mean, of course, guys, come on. So, T, first of all, you see how tricky is the examiner, guys? T is the midpoint of this now. And then they're saying this line goes to the midpoint now of this, which means if this was equals to that, it means this is equals to that. Now, what is that? Such a sneaky move from the examiner. And they want the gradient now of this. So what are they using here? They are using the midpoint theorem. That's what they are using. I hope you still remember the midpoint theorem. Now, the midpoint theorem says what? A line moving from a line joining two midpoints of a triangle will be parallel to the third side. And also it will be half of the third side. It makes sense? So now, this line is joining this midpoint and that midpoint, which means now this line is parallel to the third side, right? And now what do we know about parallel lines? Their gradients are equal. Now, but the thing is now, we don't know the gradient of this one, right? We don't know the gradient of QR. We only know the gradient of what? From this question, we only know the gradient of PQ, and the gradient of PQ was what? 3 over 5. I hope you still remember that. The gradient of this was 3 over 5. Now, look at this. We can simply say here, let me erase this quick, guys. I'm just too excited for this question. Boom, boom, boom. Right here, let's remove all this. Yeah, hope I can write on this space. Now, we said now, we know the gradient of PQ, which is equals to what? 3 over 5. We solved that, right? And then now we need to use this to find the gradient of what? The gradient of QR, right? But then we have this part here, this angle Q there. That angle, it's a 90 degrees, which says now PQ is perpendicular to QR. Now, what do we know about the gradient of perpendicular lines? We know that, oh, oops, made a mistake there. We know that the gradient of PQ multiplied with the gradient of QR, it must give us -1, because that's how perpendicular lines work, right? If you were to give a reason here, you're going to say because PQ is perpendicular to QR. Remember now, I have to teach you how to write your answer. You might know the answer in your head, but writing it down might be a problem. So now, what is the gradient of PQ? That is 3 over 5 Multiply by what? Multiply by what we don't know, the gradient of QR. That must be equals to what? -1. Now, simple algebraic problems here. How do we remove this issue on this side? We are going to multiply with the inverse of that. Multiply with the inverse. Now, if I multiply that with the inverse, I have to multiply the left side also with the inverse. Now, this whole side cancels out. I'm left with the gradient of QR being equals to negative times positive, that's negative. 1 times a fraction, that's a fraction. Right. Now, I have the gradient of QR, right? Using concepts now. And then after that, we said what? We said a line, midpoint theorem, guys. Midpoint theorem. A line joining two midpoints of a triangle is parallel to the third side, right? So if this line now is parallel to that line, therefore, does that line have a name anyway? Determine the line with the distance of the gradient of the line through T to the midpoint of PR. And the midpoint of TR doesn't have a label. So we can say now, therefore, the new line is parallel to QR. What is the reason for that? Midpoint theorem. Right? The reason the new line is parallel to QR is because of the midpoint theorem. Now we can make a conclusion. Therefore, gradient of QR is equals to gradient of the new line. Boom, right there. Easy 3 marks for you there. It was sneaky of the examiner to sneak in some midpoint theorem question there. But then there we did it, guys. It's not a problem. Now, next one. We have trig. Now, in terms of trig questions, this paper was taken from Gauteng, November 2015. Question 4. What is given there? They are saying triangle PQR. Here is PQR. And triangle SQR are right angle triangles as shown in the diagram below. Now, you need to make sure the details here, they match the details on the diagram. PR is 26, here's 26 for PR. And PQ is 24, here's 24 for PQ. QS is 8, here's 8. QSR is 6, 6. QR is 10, 10. And PRQ is theta. There we go. So now, it says, refer to the diagram above without using a calculator. Write down the value of the tangent of P. Now, the tangent of P, what do we know about the tangent? It's a ratio that compares the opposite to the adjacent, right? Okay, let's put that down. So these are questions whereby, guys, you're given a diagram and you answer those questions based on the diagram. So 4.1.1, we know that the tangent of theta, let's say the tangent of P, because we have a theta there, it compares the opposite over the adjacent now, right? So for the tangent of P, what was the opposite? The opposite is 10, which is QR. The opposite is QR over PQ. And that is equals to what? That is the same as QR is how much? It's 10. PQ is how much? That's 24. Now, for us now to solve for P, that will be the arctangent of 10 over 24. And that is how much? Let's use a calculator quick. 22 point... Oops. That is 22.62. Easy as that. So 22.62. We are talking about an angle, so it's measured in degrees. Let's write that down now. For 1 mark. That's how greedy the examiner can be. He means you should spend 1 minute on this question. Now, that's a problem to some of you, I know. So please make sure you do everything fast. So, and then the next question, it says the sine of SQR. SQR. Now the sign compares what? Now let's do it in a way as if we are saving time. Now that is 4.1.2. Let me just get to the question. We are saying the sine of SQR, which is this angle here, right? What is opposite to that? 6, because the sign compares opposite, right? And it compares opposite with the hypotenuse. What is the hypotenuse to that? The hypotenuse is 10, right? So I'm going to say 10 there. Now to solve for our question, SQR will be equals to the arc sine of 6/10, which is the same as 36.87. degrees, because we are talking about angles. So 36.87, let's write it there. Yes. And they also want the cosine of theta. So here is theta. The cosine is what? It's adjacent over hypotenuse. So let's do that. What is the adjacent for theta? That is 10. What is the hypotenuse for theta? That is 26. Right. So solving for that, theta will be equals to the arc cosine of 10/26, which means now theta is equals to how much? Theta is equals to 60 degrees, special angle. So that is 60 degrees. Now let's write that down. 60 degrees. Questions like this ones, guys, I don't expect you to struggle here. So you should always win. Next question. Let's erase that. Oops. Okay, that's enough. We are saying what? The second. Okay, that's interesting. The second of SRO. Right there. So now, what does the second mean? The second is a reciprocal of the cosine of this angle. So the reciprocal of a cosine is a second. And how do you write the reciprocal? 1 over the function, right? Now, and then after that, we move on. SRO. What is that? Oh, SRQ. Sorry. Made a mistake there. SRQ. So, SRQ, which is this one. Now, what is that? The cosine of SRQ. That is adjacent. What is adjacent to this angle? It's this number 6 here. So it's 6 over, what is the hypotenuse? Hypotenuse is 10. Now 1 over a fraction, it's the inverse of the fraction, which is 10 over 6. Now how much do we get there? We get 5 over 3. Now we can't leave it as an improper fraction. It becomes 1 and 2 over 3 this way. So let's write that down, 1 and 2 over 3. And then now, this question that you see here, this one here, this is where the examiner just tries to scare you a little bit. They are not difficult. You're just being threatened a little bit. These questions shouldn't be a problem. And when you see them, you should stop being scared of them. So I'll show you now. It's just a substitution question, and you go through them. So it says the cotangent of theta it says without the use of a calculator, right? Yeah, over the cosecant of QRS, and they want you to solve for that for 3 marks. Now, you have to understand now, when they say the cotangent, that is the inverse of a tangent, right? Now, what is the inverse of this tangent? Let me underline here so you see that these are different things. The inverse of a tangent, it's 1 over the tangent. The tangent of what? Of theta. 1 over the tangent of theta. All that over the cosecant. The cosecant now, what is that? That is the inverse of a sine. So it's 1 over the sine of this angle QRS. Easy as that. Moving on now, you have 1 over, what is the tangent of theta? Let me remove these things so that we can work properly. Use a red pen. So here is theta. Which one is theta again? I might have made a mistake somewhere. I think so. Okay. What is theta again? Theta, they say it's PRQ. So PRQ, this is theta right there. I might have made a mistake somewhere there. So please go and check if I made a mistake. So now, moving on. They said they want what? The tangent of theta. Now the tangent of theta, it's opposite, which is this one. Opposite over adjacent, right? Hope we are saying. So there we have 24 over 10. All this over 1 over the sine of QRS. So here is QRS, which is the bigger one here. Let's do it this way. So boom, 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 boom. Yeah, right. 1 over the sine of QRS. Now, what is the sine of this outer angle here? So for this outer angle, the sine is the opposite, which is 8. So we have 8 over hypotenuse, which is 10, right? So now let's fix this scenario first. This scenario, it becomes what? No wonder they said without the use of a calculator. They just want to confuse you. So here, because it's 1 over a fraction, it's the inverse of the fraction now, divided by 1 over a fraction. It's the inverse now of this fraction, which is 10 over 8, right? Hope we are set. Let me reduce this division line. It's too long unnecessarily so. So now, next, we have this fraction divided by this fraction. So which means we have 10 over 24 divided by 10 over 8. Now, according to how we know fractions is that we cannot divide fractions. So instead, we turn things into multiplications and we reciprocate the right side, which makes this 8 over 10. Right? Now, this 10 cancels with that 10, and which means now we have 1 over 24 and 8 over 1, right? Now, and then let me rewrite this in the small space here because I no longer have space. So I have 1 over 24 multiplied by 8 over 1, right? So, and then we are saying this becomes 8 over 24. When you simplify this, it becomes 1 over 3. That's the answer there. So that is that for this one. Let's move on to the next one. Moving on, guys. So here we have the Gauteng November 2015. Here's okay. I love this question, right? Okay, so Gauteng November 2015 trig question on a Cartesian plane. We are saying here, first question that we were given here, this messy one, it was a trig question when we were given a diagram. You see that? It was a nice one. It was kind. Just that the examiner sneaked in some questions there. We saw that and we solved that. So that's not a problem. And then here, now, these ones, they can tend to be tough at times. But when you master them, when you get to know them better, you get to solve them easily. So for this one, it says Houghton, November 2015. It's a trig question on a Cartesian plane. Always expect that you will get a trig question on a Cartesian plane, whereby you're supposed to use a Cartesian plane for you to solve that question. I hope we are set on that one. Okay, so here, the first question for question 5. Oh, here's an NB. Let me read this. It says, if this question appears with a terminal that is in the first quadrant, then that is your lucky year. Because as you see now, the terminal is not on the first quadrant, it's on the third quadrant. Okay, but then even if that's the case, that is fine. Just that if it was on the first quadrant, it was going to save us a lot of time, but still, that's not a problem. Here the question says, in the diagram below, coordinate P, here's coordinate P with this is a point in the third quadrant, and ROP is equals to beta, and 17 multiplied by the cosine of beta plus 15 is equals to 0. Now, that is interesting. The first question says 5.1.1, write down the value of x and y and r. Nice. So I want to focus on this equation now. Quick. This equation is nice and interesting. When we say 17 cosine beta plus 15, oh, sorry, what did I do there? I'm ahead of myself. Plus 15 is equals to 0. This 15, please bear in mind, it's not part of beta. It's not the angle. The angle is only beta here and not the 15. The 15 is attached to the whole thing. I hope that is fair. So 17 cosine beta, this, we are adding it to 15. No, sorry, why do I keep on writing degrees? We are adding it to 15, right? We are not saying an angle plus 15 degrees. 15 is not an angle. Let's start there. 15 is not an angle. I hope that makes sense. So let's move on here. Delete that. It's always the small matters that give us a problem. Right there. So now 5.1.1, they are saying here, write down the value of x, y, and r. So we use this equation that was given to us to answer them. Usually, as the examiner gives it to you, the questions, they lead you to the next one. So for you to answer the next question, you would actually need the answer of the first question. So if whatever you got on the first question is wrong, just keep on using it on the next question and positive marking will apply. So here we have 17 cosine beta plus 15 is equals to 0. So what I want to do here is that 17 and the cosine of beta, I equate that to negative 15. How's that possible? I just transposed the 15 to the other side, right? From this binomial of this term and this term, I transpose the other term to the other side. Is that fair? Good. After that, I isolate 17 from the cosine. So I divide this side by 17. I also divide this side by 17. So this cancels that. I'm left with the cosine of beta being equals to negative 15 over 17. Now, in this case, what happens? You need to understand that the negative, is it for the numerator or the denominator? And because we have the cosine, what is the 15 for? What is the 17 for? Right? So, the cosine compares what? It compares x with r. Right? Now, because we have a negative here, does the negative belong to the x or the r? It belongs to the x because r is always positive. So it means here, let me put an arrow there. I have x over r, right? Which means now, therefore, my x is equals to negative 15 and my r is equals to 17. All set? And now I need to find y. And how do I find y? I come to this diagram and then I form a triangle. The triangle that is formed here It's always a right angle triangle, and that right angle triangle, it's always attached to the x-axis. Now the r is the terminal, that is the hypotenuse, the y is the y component of the triangle, and the x is the horizontal component of the triangle. I hope that is fine. So I already have the horizontal component because I said this is negative 15, which makes sense because it's on the left side of the Cartesian plane, and here x is negative. And then I have my r is 17. Now what I'm looking for, it's the y. I hope that's fine. So now looking for y in this case, I'm going to say, let's remove all that. I'm going to say here Pythag. I'm going to say r squared is equals to x squared plus y squared. What is the reason? My reason is Pythag. Is that fine? Now what is my r? My r is 17 all squared. What is my x? My x is negative 15 all squared. You see how the square covers the negative 2, yeah, and plus y squared, right? And I have to isolate everything from y now, which means I'll transpose this to the other side, which becomes 17 all squared minus negative 15 all squared. That is equals to y squared. Makes sense? Yes. And then how do I remove the square from the y? I put a square root to remove the square. It makes sense. And if I put the square root this side, I also have to put a square root that side. But then because I'm solving, this square root will give me a plus minus, right? So which means now, let me rewrite this thing in a way that you would understand. I have plus minus 17 all squared minus negative 15 all squared, and all this is under a square root this way. Therefore, which means my y will be a plus minus the answer I get once I punch this on the calculator. Let's do that quick. How much do we get? We get 8. That's our answer. So which means now our answer is plus minus 8, right? But then looking at the terminal, look at this. Our y is below the x-axis. Let me show you here. Our y is below this x-axis. So is y below the x-axis a negative y or a positive y? It's a negative y. So which means now here, after I found my answer, I have to choose between this plus minus. Am I taking a plus or a minus? My y is negative because it's below the x-axis. There we go, guys. Easy 4 marks for you to collect. So let me write y there in case I don't forget it. In case I forget it, not in case I don't forget it. Oh, what am I saying? Okay, it's negative 8 right there. So now moving on to the next question. Without using a calculator, determine the value of the sine of beta. Ooh, look how nice it becomes. Look how nice it continues. Let's remove the detail here and start solving. So we were saying 5.1.2a, they said without the use of a calculator. Now in Trig, when we are saying without the use of a calculator, we are telling you that never give us your answer as a decimal. You can give it to us as a fraction, a mixed fraction, a whole number, a third or whatever, but don't give us your answer as a decimal. That's what we mean when we say without a calculator. The sine of beta. So what does sine compare? A sine compares y over r. So a sine of beta here, I'm just going to take my y value, which is negative 8, over r, which is 17. Here's a math there. You see how easy is that? Some people might not even believe that this is the answer. Like, this is it, guys. Never gets better than this. And then next one. It says the square cosine of 30 multiplied by the tangent of beta. Look at this one. What happened here? What happened here? They said we don't use a calculator, and then they gave us a value which we didn't have at 30 degrees. Why? Because 30 is a special angle, and they expect you that you should know the ratios of special angles, right? So the examiner, for some reason, he expects us to cram the triangles of the special angles. Now I urge you to only cram the triangles of the 45 degree. Yeah, that's it. The ratios that come with the special triangle of the 45 degree triangle, that's all you need. Everything else, use a calculator, even if they said do not use a calculator. Let's show you what we mean by that. In fact, let's do this. So the square cosine of 30, we know that we are going to have a ratio, and we square the whole ratio. Now we need to know what is the cosine of 30 degrees. You are expected to know that from the special triangles, but for someone like me, we don't use the special triangles. I just go to my calculator, the very same one they said I shouldn't use. I press the cosine of 30. I just know that my answer shouldn't be a decimal. Boom, I get a fraction. That's all I need. Root 3 over 2. And then I come here, I write that root 3 over 2. Multiply that with the tangent of beta. Now the tangent of beta comes where? From this diagram. The tangent compares what? It compares the y over the x. Now what is my y value? My y value is negative x, negative 8. What is my x value? My x value is negative 15, right? And then from there I just solve. When you square a surd or something that has a square root, the square and the square root, they cancel out. I'll be left with the 3. And then now, because I'm squaring this whole thing, the square applies to the numerator and the denominator. So I also have to square the denominator. Squaring 2 gives me 4. And then this is a negative and a negative, which is positive. Then I have 8 over 15. How nice is that? Now, let me use a red pen here, because people think I'm cancelling when I keep on using the same pen. I'm saying 3 into 3 goes once, and 3 into 15 goes 5 times. 4 into 4 goes once, and 4 into 8 goes 2 times. You can do this, or you can do this manually. You'll still land where we are. Hope that is fine. So this fraction now, I have 1 over 1 multiplied by 2 over 5. What does 1 over 1 multiplied by 2 over 5 give me? 2 over 5. Easy as that. Oh, how nice was that? It's so fulfilling to solve. I wish I can do it again. I wish they can surprise me with something like that again. Like, I wish I can do it for the first time again. How nice is that? You see that? You just have to master those things, and once you do that, it becomes enjoyable for you to solve. But remember, guys, when you are in an exam, don't lose to time. Whatever you do, don't lose to time. So, and then here it says calculate the size of ROP correct to 2 decimal places. ROP correct to 2 decimal places. Oh, how nice is that? Looking at what they told us, that ROP is our beta. Here's how we do it. We know that from here, okay. How do I say this? Okay, let's say, look at this angle. Let me use a different color here. Boom, boom, boom. Look at this angle. This is not a different color. Right here, yeah. Look at this angle here. Just this one alone, right? This is an acute angle. It's acute, right? I want to work with that alone now. Not this whole thing starting from here up until there. Just this smaller angle here, this acute angle. So for me to work with that acute angle, I know that in this triangle, I will have to forget the negatives and work with only the positive values. Because if only I work with the triangle and not the Cartesian plane, then I do not have the negatives. I just have the values, right? So now, if ever I have this small area here, and I want to know how much is this angle, how would I know that? I can just use this and use that as a cosine, right? So I can just say the cosine of this angle that I don't know, let me call this angle Z. Yeah, the cosine of Z is equals to the adjacent. What is the adjacent? It's this 15 that I see here, the 15 over what? The hypotenuse, which is 17, right? And now how do I solve for the angle Z that I'm looking for? That is equals to the arc cosine of 15 over 17. And that would give me how much? It will tell me that angle Z is equals to, let's use a calculator for that. The arc cosine of angle Z, which is 15 over 17, that is equals to 28,07, right? Perfect. So this is 28,07 degrees. That is the angle here that is shaded, right? But then now they're looking for the whole beta. The whole beta starts from here. Let's use a different color again. Boom, boom, boom. Right here. The whole beta starts from there up until there. Up until the terminal here. Starts from here up until the terminal. Now, the whole beta includes this straight line plus this acute that I just calculated. All set. Perfect now. So, if that's what the whole beta includes, it means now, for me to be able to calculate the angle from here up until there, I'll need to know that this is a straight line. And a straight line, it's how much? It's 180 degrees. Right? Plus the small angle in here, the one that I called angle Z. How much is angle Z? 28,07 degrees. Now, which means now the whole of angle beta is equals to the 180 degrees plus boom, boom, boom. Yeah, I hope it makes sense. So this would give me how much? How much? This would give me 101.08. Let's use a calculator because my mind is everywhere right now. 180 plus 28,07. Boom, boom, boom. Is the 208,07, which makes sense because this angle is above 180 degrees, but it's less than 270 degrees. So that is 208,07 degrees. Let's do that here. 208,07 degrees right there. Boom. How nice is that? Now, next question, guys. If there's a question whereby you have a fighting chance, guys, not just a fighting chance, a higher chance of winning, it's this one. It says, in each of the following equations, solve for x, whereby x is an acute angle. Give your answer correct to 2 decimal places. Guys, look at this one. So for this one, for 5.2.1, it says now, here I can just use the arc tangent of 2,22 and see how much I get. I'll use a calculator for that later on. Next one, I have 5.2.2, whereby it says the second. Now that's interesting because which means I have to rewrite this as 1 over. The second is the reciprocal of which function? Of the cosine. So here I have cos x plus 10 degrees. You see that? You have to make this 1 over the cosine of x plus 10 degrees because the second is the reciprocal of the cosine. So that is equals to what? 5,759, right? And now I'll switch this around so that it becomes cos of x plus 10 degrees, which means I'll also have to switch this around. It becomes 1 over 5,759. All set. Hope that's okay. And then I can do the arc cosine. I can say x plus 10 degrees is equals to the arc cosine of this fraction here, which is 5,759, right? And then I have x plus 10 degrees. It's equals to, now I can pull out my calculator. The arc cosine shift cos of a fraction, which is 1 over 5, 759. Let's close the bracket. How much do I get? 80, a perfect 80, because to 2 decimal places that's an 80, guys. So that's 80 degrees. So on this side here, I'm just going to say 80 degrees. Now how do I solve for x? I transpose the 10 to the other side, which becomes a negative 10 degrees. And my final answer for x is 70 degrees. And let's also answer this one. I know that you probably have an answer for this one by now. You just say the arc tangent of 2,22, that gives you 65,75. See that? 65,75. So there we have 65,75 degrees. See that? Killing 2 birds with 1 stone. Now I'm left with one question. Let me erase that. Perfect. Let's also erase this. Okay. Oops. No. Not my guy. Hey. Oh, oops. Let's use a normal eraser. Otherwise, I'll remove my guy there on the right. And I can't work without looking at these guys. No ways. Perfect. Now, here we go, guys. And then 5.2.3. Let's do 5.2.3. 5.2.3, it looks scary, but it's not. It's really not. So it says the sine of x all over 0,2. Oops, what did I do there? All over 0,2. So I'll say 0,2 minus 2, that is equals to 1,24. Now the first thing here is to realize how many terms you have. You have 2 terms. You have this term and you have this term, which is negative. So the first thing you do is that you remove the other term to the other side. So you send 2 to the other side. So 1,24 plus 2, right? And then you will have what? Let's use this side. You will have sine x over 0,2, that is equals to 3,24. I guess so. Please use the calculator to check. And then after that, you have to remove 0,2 to the other side. How do you send 0,2 to the other side? That one is a denominator, so you multiply with something that's a numerator on both sides. So let me rewrite that. You have sine x over 0,2, multiply this with a numerator of 0,2, therefore, which means this side you'll also multiply it with 0,2. Makes sense? What did I do there? Sorry. I told you guys, the longer I work, the more I'm more prone to do mistakes, and I have to do a lot of guarding of this software not to crash. Okay, and then here I have how much? I have 3,24. Multiply that with 0,2. How much do I get? Let me see if I can have a decimal. Oh yes, 0,648. I know we said to 2 decimal places, but this is not the final answer. So don't go to 2 decimal places before the final answer. So 0,648. So right here, I'm going to say 0,648. After that, I can just say x is equals to the arc sine of 0,648, which gives me how much? Let's see. Let's clear this. The arc sine of 0,648, right, gives me how much? Let's close the bracket. Let's close the bracket, guys. Every time you open the bracket, please close it. 40,39 degrees to 2 decimal places, of course. 40,39. So there we go. 40,39 degrees. Did I write that? So good. Yeah, 40,39. There we go, guys. Easy peasy lemon squeezy. So more trick question. Here's a question from Eastern Cape. They are saying prove the following without the use of a calculator. Okay, it shouldn't be a problem because we know we'll use a calculator, just that we won't show the decimals. Okay, and then for 5 marks. So the reason they say for 5 marks, it doesn't mean you need to have 5 steps. Just do whatever you know. And even if it's not 5 steps, if it's 3 steps maybe, just do whatever you know. You'll get the 5 marks, don't worry. They are just saying you should do this in less than 5 minutes, which of course you will do it in less than 5 minutes, especially on a test, because unlike me, you won't be doing it, explaining it to anyone. You'll just be doing it. Okay? So, let's get straight to it. I have this fraction here. They are saying the sine of 30 without a calculator, but I'll pull out my calculator there. Then we're saying the sine of 30. How much do we get? 1/2. So right there, what's happening now? Sorry guys, some technical error here. Yeah, so 1/2. This is 1/2 multiplied by the tangent of 60. Guys, if you crammed this thing, then good for you. Thank you for doing what you were supposed to do. But as for us, we'll use a calculator. √3. Now when it's √3 now, it's tricky because they'll see if you use the calculator here. So you are supposed to write this as a fraction. So what is √3 as a fraction? √3/1. Perfect. Let's do that. So √3/1. Next one, the tangent of 30. So here you have tangent of 30. How much do you get? √3/3. So let's do that. This is √3/3 multiplied by the cosine of 60. I'm sure most of you know the cosine of 60, but I don't. 1/2. There we go. 1/2. 1/2. Now we don't have to stress ourselves too much with this one because we can already see that. Let me put this here. We can already see that this one. Let me use a red pen so that it doesn't look like I'm cancelling. This fraction you can cancel out with this fraction, right? Yeah, of course. And then I'll be left with √3/1, all that divided by √3/3. Now, what does this mean? It means this fraction, which is √3/1, divided by this fraction, which is √3/3. Right? And then remember, when it comes to fraction, we cannot really divide, so we have to rewrite this. So this is the same as multiplied by, you reciprocate this one, you put the 3 above, you put this one this way, right? Then you can cancel this part with this part, and then you'll be left with 3/1, which is the same as 3. Easy as that. So whenever you have to do something difficult, give it to a lazy person, and that lazy person will find a way to do it much faster. Hence we use a calculator when they say we shouldn't. Another one, it says simplify the following expression without using a calculator. Right? Here we go again. The cosine of 0, it's also a special angle, don't worry. So pull out your calculator there. Say the cosine of 0, that is 1. So you just go there, you're going to say 1. So a cosine doesn't form a triangle, so you don't have to rewrite it as a fraction. I mean, 0 degrees doesn't form an angle, so you don't have to rewrite it as a fraction saying 1/1, okay? So we have 1 plus the square sine of 60 degrees. Now this is tricky because it means you have to take the sine of 60 degrees and square it, I hope it makes sense. The square sine of 60 degrees. So you have to take whatever that is the sine of 60, square all of that. So here I'm going to say sine 60. Oh, sorry. I'm going to say the sine of 60 equals to root 3 over 2. So there we have root 3 over 2, right? Plus the root of 2 multiplied by the second of 45. They're trying to be tricky again. A second is a reciprocal of a function. It's an inverse of a function. Maybe not an inverse, a reciprocal of a function. So a second is an inverse of what? Of a cosine. So this is cosine of 45 degrees, right? So now I have 1 plus, can I solve this before I move on further there? This, when I square a square root, the square root flies away. I'm left with the 3. And the square applies for the numerator and the denominator. So when I square the denominator, I get 4 plus root 2 multiplied by 1 over the cosine of 45. Now I go there again. Cosine of 45. Oh, sorry. Cosine of 45. I get how much? Root 2 over 2. So there we go. I get root 2 over 2. As long as I write it as a fraction, don't worry guys, they won't know. They won't know that we use the calculator. And then I have root 2 here multiplied by this. I have to fix it. If it's 1 over a fraction, it means I have to turn the fraction around. So it's 2 over root 2. Now let's use a different colored pen here. Here I have this numerator which can cancel with this denominator, which means now I'll have 1 plus 3 over 4 plus 2. Hope it makes sense. And then now I see if there's denominator 4 is a mood breaker because I have to convert everything to the denominator 4. What is 1 if it has a denominator of 4? That is 4 over 4 plus this 3 over 4 plus this 2. How do I write 2 that has a denominator of 4? That is 8 over 4. Right? Hope you know those things, guys. Then I add them together. Because they said without the use of a calculator, I have to show the steps, guys. So the denominators are the same. We keep one denominator. Right? And then I add 4 and 3. That's 10. What? 4 and 3, it's 7. And then 7 plus 8. 7 plus 8. How much is that? 15. Alright. And we can't leave our answer as an improper fraction. So we have to simplify it. 4 goes into 12. How many times? 3 times. The remainder for it to reach 15 is 3 all over 4. So that's your final answer. Nice. Moving on. Then now we move on to trig graphs. Trig graphs are easy, guys. You just need to understand trig graphs and then all that will be solvable for you. So here we have two types of graphs. We have the sine graph and we have the cosine graph, right? So from the sine graph, here we go. So we are not given any details of the equations of the cosine graph and any detail for the equations of the sine graph. But we can, oh guys, I'm tired. I've been at this video for a long time now. And remember, I've been pausing and calculating on my neck. Oh, on my days. Okay, yeah, where was I, guys? Let me not lose track here. 6.1 here. They say write down the values of A and B. A is for the sine, B is for the cosine. What do the A's represent in that case? They represent the, give it to me, the amplitude. They represent the amplitudes, right? So here, now the amplitude, what is the amplitude? For you to find the amplitude is half of the maximum value minus the minimum value. or half of the highest value minus the lowest value. That's what we mean by that. So you have to identify which graph is the cosine, which one is the sine. So here they already told you that this is an F graph. So an F graph is the sine graph, and this G, they told you that this is the cosine graph. So F, that's where A is. Let's do this. My A is equals to half of the maximum value minus the minimum. Substitute that, half of, what is the maximum value of the F graph? The maximum value is 2. The minimum value is what? -2. So I have 2 minus -2. You cannot put two signs close to each other like that. They have to be separated by some form of a bracket. Therefore, my A is equals to half of this, gives me how much? 4. So half of 4 is how much? It's 2. So my A is equals to 2. Hope that's fair. Moving on. Oops. Let's delete this and erase the other ones too. Boom, boom, boom. I have to find now the value of B. B is also the amplitude. So B, you also do the same. B is equals to 1/2 of the maximum value minus the minimum value. Therefore, which means B is equals to half of, what is the maximum value in the graph of G? It's 1. The minimum value is -1. So I have 1 minus -1. I cannot put signs so close to each other. I'll separate them by brackets. Therefore, B is equals to half of, what is 1 minus -1? That is 2. And half of 2, that is 1. Therefore, B is equals to 1. Easy as that. Guys, trig graphs. Easy, those things. Trig graphs, easy. I walk over those things. And then for which values of x will G be? For which values of x will G be a decreasing function? So we are talking about G here, right? Let's stick to G. So for G, where will it be a decreasing function? Now, how do you find that one out? We read the graph from left to right. So as we are moving from left to right, if we are going down, we are decreasing. If we are going up, we are increasing. Hope that makes sense. So now this one here, right there, let's use red for decreasing so that you get it. As we move here, we are going down. We are what? Decreasing, 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 up until here, right? From here, as we move, we are going up. So we are doing what? Increasing, 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 increasing. That's for the graph of G. Yo, I'm wasting time. Now, for which values of x is the graph of G decreasing? For which values of x? So you go there and then you say, when x is found from, when x is bigger than, which means it doesn't include that. What is the x value here? We want to know when x is bigger than this number. What is the x value here? 0. So when x is bigger than 0, the graph is decreasing. Up until where? Here. What is the x value here? We want to know when x is less than this number. When x is less than 180 degrees. So less than 180 degrees. We put curve brackets because it's less than, not equals to. When x is equals to 180 degrees, the graph is not decreasing. It's constant there. And when x is equals to 0 degrees, the graph is not decreasing. It's changing directions there. So I hope it makes sense. So when x is bigger than 0 degrees, the graph is decreasing. And up until where? Up until 180 degrees. That's the max, right? Or you can say when x is less than 180 degrees and when x is bigger than 0 degrees. You can also write it for me this way. I can also take it. So let's write it down here. when x is found between 0 degrees and 180 degrees. All set? Perfect. And then they're saying, what is the amplitude of f? Here's the graph of f. We said, what is the amplitude? We calculated this one. We said the amplitude is the maximum value minus the minimum value. So the amplitude is what? Is half of the maximum value minus the minimum value. That's what we said. Half of the max minus the minimum value. That's how you find the amplitude. So what is the maximum value? That is 2. It's right in there. 2 minus the minimum value, negative 2. So which means we are looking for half of 4. And how much is that? 2. So the amplitude is how much? It is 2. Oh, we should have just found it here. What is the range of G? The range of G. The range of G, we are talking about the y values, all the possible y values in this graph, right? So what are the possible y values in the graph of G? We know that the graph of G, for some reason, it's reaching positive 1. It goes down, it goes down, it goes down up until what? Up until negative 1. It goes up again up until what? Up until positive 1. It keeps on playing in this range. You get the logic, the range. It keeps on playing into the range of positive 1 and negative 1, right? So the graph will reach the high of positive 1 and reach the low of negative 1 at all times up until it will keep on moving like that, right? So let's put it in mathematical notations now. So for us to answer that properly, we are saying our y values, they'll play around, they'll always be less than positive 1, but they'll always be greater than negative 1. Easy as that. Or you can rewrite it this way and say y is found between negative 1 and positive 1. Easy as that. Moving on, 6.5. For which values of x is f of x minus g of x equals to 2? Hope that makes sense. We are saying, where can you take the y value of f and minus the y value of g and end up with the answer of 2? Let's go to the graph. Let's do that. Let me choose a different color here. So we are saying, where on this graph can you take the graph of, which one? The graph of f minus the graph of g and get 2. Here's the graph of f, guys. Here's the graph of f right there. The only point where the difference of these two graphs gives me 2, it's here. Hope you see that. Because if I take the y value here, how much is the y value of this graph? That is 2. How much is the y value of this graph of, this is the graph of f, right? F is 2 here, and g is how much here? It's 0. So if I take this graph, I minus this one, I'll get negative 2. So they're saying, on which x values is that statement true? On the x value of 270 degrees. So when x is 270 degrees, that statement is true. Let's move on, guys. I'm wasting time on these things. Oh, look at those things. We still have some more to go. And these ones are interesting. Now let me take a quick break, drink some water, and then I'll come and do these ones. So please attempt them on your own. I'm talking like we're on a live session, but yeah, please attempt these things on your own, and then before you proceed, then you will get the answers from me. Gauteng Provincial Exam, November 2022. Here it's talking about the midpoint theorem. If you do not read the statement properly here, you will get chowed. Okay, guys, you need to master the midpoint theorem. It usually carries a lot of marks, and if you master this thing, you are winning. Okay, question 10, it says, in the diagram below, D and E Oh, let me show you where I'm reading. In the diagram below, D and E are midpoints of sides AB, and the side BC of the triangle ABC. Point P is on BC, so P is on what? Point P is on BC. Okay, I think they made a mistake there. They were supposed to say AC. Point P is on AC. Such that PA is equals to PB. Right. And then it says PB. Here is PB. Cuts DE at R. They didn't say equally so or in half. They just say it cuts it at R. Right. So then now the question says prove that triangle A what? Okay. Prove that triangle RDB is isosceles. Okay. Let's see. So what we have here is that we are told that this side and this side, they are cut by this DE line, right? So it means now DE is parallel to AC. Why? By midpoint theorem, right? DE is parallel to AC by midpoint theorem. What else can we say here? What else can we claim? We can also claim that DE is equals to half of AC. Why? Midpoint theorem. Due to midpoint theorem. Right? So now, since we know now that this line is parallel to this line. Oh, also one thing that they told us, we forgot to identify that. They said PA is equals to PB. So here is PA supposed to be equals to PB. Right there. We all see that. So which means now this angle and this angle are equal. Guys, it's even coming together now. We don't need this thing. We don't need this statement that I just wrote here. Let me erase it. This second statement, it's not necessary. Let's delete that. So after we said that the lines are parallel, that one we needed. We're also saying that now AP is equals to PB. Why? It's given. They told us AP is equals to PB. Therefore, angle A is equals to angle B1. Why? Isosceles triangle APB. This triangle, this one, APB, it's isosceles because this side is equal to that side. Right? Perfect. After that, this is straightforward. After that, we can say D2 is equals to angle A. Why? These are alternating angles using which parallel lines AP is parallel to DR. The reason we are saying AP is parallel to DR is because we proved it before. Let me highlight that. DR is parallel to AP. We proved it before using these symbols. Right? Yeah. And then we can say, therefore, angle D1, angle D2, it's equals to angle A, and they're all equals to angle B1. Proven. Therefore, dr, the side dr, here is dr, is equals to the side RB. Why? Base angles of triangle ABC. Not ABC, sorry. Base angles of triangle RDB. RDB. So we are saying this side, this side and this side are equal in this triangle RDB, right? Why are they equal? They're equal because this angle here, D2, it's equal to this angle here, B1. Base angles of that triangle. Therefore, if the two sides are equal, therefore, triangle RDB is an isosceles. What is the reason? We use base angles of an isosceles to prove it. We use base angles of an isosceles triangle to prove that case. Easy as that. Next one now. So this one is a challenging one. It's a tricky one. I hope you will find it. And if you are not doing so, please make sure you pause the video, attempt the question on your own first before you move on. Okay. So now here, with the statements we are given, this one, when you see it, it will really give you some chills. But I know there are people who can still do it. So let's start here. Do you see the side? Let me use different colors for notating here. Do you see the side here, TS? Let me start. I don't even know where to start. But let's see. You see this triangle here? Right there. I want to highlight the triangle for you here. Oh, it's a little bit unperfect, but yeah. You see this triangle? This triangle has a line in between here, right? And you have these sides indicated there. Which concept works there? That's the midpoint theorem. You do know that a line joining two midpoints of a triangle is parallel to the third line of that triangle. We are looking at the red triangle. Do we see that? So because this line TS, it joins two midpoints of the triangle, it means TS is parallel to UR. So I can say that. I can say TS is parallel to UR. My reason for that is midpoint theorem. Right? All set. Now let me remove these indications here now, whilst you're still processing what I told you about now. So if that's what we said now about that triangle, let me leave this one here. We said this line is parallel to that line, right? All set. So what if now I start considering this triangle now, this one here? Do we see that? Already I know that this line UV is parallel to TS because I proved it there. You see this arrow here and the arrow there. I already know that UV is parallel to TS, right? So I can simply say, if that's the case, then since this angle is x, this one must be how much? 2x. Make sense? Because that's what the midpoint theorem converse says. So here I know that uv, right, is equals to half of ts. Let's not say it this way. Let's not say this way. Let's say it this way. Let's say uv is equals to x, therefore ts is equals to 2x. Make sense? uv, it was given that it is ts, and then therefore ts is equals to twice the length of uv. Why? Because this is the converse of the midpoint theorem. It's the converse of the midpoint theorem. The converse of the midpoint theorem says when two lines are parallel in a triangle, that line then, no, it's not the converse, sorry for that. It is the midpoint theorem. Midpoint theorem. Because the midpoint theorem says a line joining two midpoints of a triangle is equal and is parallel to the third side, and that line is equals to half of the third side, right? So now I know I already proved that this line is parallel to this one. Therefore, it means now in this triangle, the line that is parallel to this one and joining a midpoint is half of the third line in that sense. I hope it makes sense. Ts is 2x when uv is x, right? Yeah. And then after that, after I found ts, now I move back to the main triangle line now again, which is what is tricky about this triangle. I keep on moving between triangles, right? Let's do this one first, the one that we proved. Boom. Yeah. And then moving on to this one again, to this triangle again. To this triangle again. We said this side it is 2x, right? That's ts. Now moving back to the midpoint theorem again, we said the line joining two midpoints in a triangle is parallel, which is what we proved already, to the third side, and this line is half of the third side. So therefore it means, therefore if ts is equals to 2x, then ur is equals to 2 times ts, which is 2 times 2x. Why? Still the midpoint theorem. All set. If this side is 2x, it means this whole line, it's how much? 4x, right? So therefore ur it's equals to 4x. All set. Now that I've found the whole line ur, I can remove uv. So vr is equals to ur minus uv. That is the same as vr we are saying ur is equals to, vr, what's happening with me? Vr is equals to, how much is ur? Guys, sorry for making this mistake. Really apologize. Let me do this thing again properly. So we said UR is equals to 4x, right? Now, for me to find VR, which is what they want from me, I'm supposed to say UR minus UV, right? Therefore, for me to find VR, I substitute here. How much is UR? UR, I said it's 4x. So I'm going to say 4x minus, how much is UV? UV is x. Therefore, how much is VR? VR is 3x. That way, 6 marks taken. Hope you understand that. Let's move on now. And now we move on to more convenient Euclid problems. I love these ones. These ones, they'll never give you a problem. These are nice Euclid problems. This is where you score marks. So, don't worry, guys. I'm sure most of you see that, hey, now we are on like 1 hour 45 minutes. Hey, does this guy wants to teach the whole day on YouTube? No ways. No ways, guys. I'm almost done now. Don't worry. We won't cross until tomorrow. So here, question 8, it says, KLM is a rhombus. That statement alone, it speaks volumes. Not volumes like the one you know in maths, but it speaks volumes. KLMN is a rhombus with diagonals intersecting at O. Now, when they say something is a rhombus, that's a bold statement. That's a lot of characteristics mentioned there. Now, let's put those characteristics into effect. Then we'll remove them if we need to see the shape properly. If this is a rhombus, parallel lines, this side it's equal and parallel to this one. This one it's equal and parallel to this one. And all sides are equal, right? Perfect. That one it's annotated. And then again, what do we know? A rhombus here, it intersects at 90-degree angles, right? And then also, what do I know? I know that this side is equal to this side, and I know that this side is equal to this side, this way, right? What else do I know? I know that this angle is bisected by its diagonal, and this angle also is bisected by its diagonal. Perfect. I also know that this angle is bisected by its diagonal, and I also know that this angle is bisected by this diagonal. All set? Perfect. Now, that's what properties of a rhombus say. Once they tell me that something is a rhombus, I have to put those qualities into effect. Now, let's move on. Let's hear what the questions say. Write down the size of O1. Oh, we already did that. Let's just put it down here. O1 is equals to 90 degrees. It's 1 mark, and they never said we should write the reason. So, yeah. Or you can just write it. Properties of a rhombus. Okay? Yeah. 8.1.2, calculate the size of L1. Where's L1? Here is L1. You see L1. So how do I find L1? If I take this L1, I add the 34 degrees, I add the O1. I must get how much? 180. So let's write there. L1 plus 34 degrees plus O1 is equals to 180 degrees. Reason, sum of interior angles of a triangle. Let's not destroy Kakashi there. Yeah. See that? And then now that's angle L1. Put an angle cap to show us that you're talking about an angle. So now L1 is equals to 34 degrees plus how much is O1? 90 degrees. That is equals to 180 degrees, right? And then now we can say L1 plus how much is that? Let's pull out my calculator. 34 plus 90 degrees, that is 124 degrees. I'm sure some people are like, what kind of a teacher is this? You don't know that this is 124 degrees. Guys, sorry guys. 124 degrees. It's equals to 180 degrees. Then angle L1 is equals to 180 degrees minus 124 degrees. Therefore, angle L1 is equals to, pull out my calculator again, we have 180 minus 124 degrees. That is 56 degrees. So our angle is 56 degrees, guys. They said 2 marks. They didn't say 2 marks because they want 2 steps. They said 2 marks because they want you to spend 2 minutes on this question, max. 120 seconds. That's enough, guys. Come on. That's enough. So L1 is 56 degrees. There we go. 56 degrees. Let me write it here too. 56 degrees. Perfect. You see, annotating a diagram, how nice it is for you. It simplifies everything. You just look at it here on the shape. You don't have to think about it. You look at it, then you see it. Okay, calculate the size of K, N, M. Let me see it. K, N, M. M. This one. Oh, come on, guys. Sorry. Didn't write that properly. Like, they're talking to me about this angle. Guys, that's a joke. This one should be a joke. Okay, first of all, this is easy, guys. If you ever get something as easy as this one, you must be cocky. There's no way the examiner can be this lenient. Like, come on. Okay, this one is 56 degrees. N2 is 56 degrees. Why? Angle N2 is equals to 56 degrees. Because those are alternating angles. It alternates with this one here. Which parallel lines are they using? You can't give me a reason that has parallel lines without telling me which parallel lines are those ones. So here we have NM that way, right? And then we know that N1, as we said here, this angle N1 is equals to that angle there. That's how it is. So N1 is equals to the angle N2, and they're all equals to 56 degrees. What's the reason? Diagonals of a rhombus bisect angles. We know that the diagonals of a rhombus, they bisect its angles. So that's how it is. So therefore, now we haven't answered the question. Some people will leave it there and forget to answer the question. Therefore, angle KNM is equals to 56 degrees plus 56 degrees. Let me try this one without a calculator, otherwise I'll lose my points. 6 plus 6 is 12, so this is 112 degrees. There we go. There we go. You see, who needs a calculator, guys? Then moving on, these are the last topics, as you can see there. These are the last. I'm guaranteeing you these are the last ones, guys. So I have a video on how to derive a formula of a cylinder. Please go watch the video, and it shouldn't be difficult for you guys. It shouldn't be. So super easy. So now I'll solve this question as if you know what I'm talking about when it comes to deriving a formula of a cylinder. And then if you don't, after watching this video, because now we are towards the end of this video, after watching this video, please go back and rewatch that video and you will see it. It's so nice. It's so nice. Not me promoting myself. Okay, here's a cylinder. Find the surface area of the following cylinder correct to 1 decimal place. You've been told here, even though the exam instruction says you provide your answers to 2 decimal places, in this case, it's an exception. Here we want 1 decimal place. Right, it says find the surface area of a cylinder. The surface area of a cylinder, we add all the areas. So the diameter here is 10 centimeters. When we say we add all the areas, I need the area of this circle above. Area of a circle, it's pi r squared. The area of a circle below, it's also pi r squared. So we have 2 pi r squared, right? And then plus the area of this rectangle here. The top part of the rectangle is the circumference, which is 2 pi r, multiplied by the vertical part, which is the height, right? By now you should be able to derive a surface area formula with me for a cylinder. Come on, guys. And then here we substitute 2. Do we have a value for pi? No. So we use the pi symbol on a calculator, as we said in the previous video. And then the radius is how much? It's 10. We square that plus 2 pi symbol. Substitute 10. How much is the height? 30 centimeters. Now that's 30 centimeters. Now that's an easy one to solve. then surface area is equals to, you see, after doing this, you don't do step-by-step things. You'll end up making a mistake, guys. Just substitute the whole thing on a calculator. The calculator will do the heavy lifting for you. Don't strain yourself. Let me punch my numbers properly. Shift pi multiplied by 10 brackets exponent plus 2 pi times. When you don't put a multiplication, you'll get an error sometimes. So wherever you should put a multiplication, put a multiplication. 30. Okay. How much do we get? 800 pi. Did I say we should leave our answer in pies? Or to one decimal place? Sorry. 2513,3 to one decimal place. Remember that. 2513,3. Let's write that down. 2513,3. 2513,3. What is the unit used to measure area? That's square centimeters. Right there. Right? The last question. I guarantee you this is the last question. You see. What do I want? Find the surface area of the following rectangular prism. Now, to derive a surface area of a rectangular prism, also there's a video for that. You are going to say surface area is equal to, let's see, you have this side on the left, it has a pair on the right. Let's call this the breadth, let's call this the length, let's call this 2 the height, right? So to derive a formula, you have this side on the left, which is the breadth times the height. So it's breadth and height, and this side appears 2 times, so you say 2 plus the side above. You have this side, which you call it the breadth, and you have this side, which you call it the length. And we have 2 of those sides. We have the one above, we have the one below here. So that's 2 plus you have the side in front, this one, the face in front, and the face there at the back. What are the dimensions? You have this side, which is the length, so length times this dimension, which is the height, so times the height. So we have 2 of those sides, because it's this one and the one at the back there. So that's the formula for surface area of a box. And then now you substitute. You have 2, length it's how much? 10. Height it's how much? 2. Plus 2, breadth it's how much? 5. Length it's how much? 10. Plus 2, length it's how much? 10. Height it's how much? 2. And then don't try to include other steps and things like that. Let the calculator do the heavy lifting for you. You see that? Things that are meant to be calculated, put them on a calculator. Don't calculate with the head. The head is for thinking, guys, not calculations. So here we go. Let's put everything together there. Press AC or on. Some people like restarting the calculator with an on. And then we have this, and then multiplied by 2 plus 2 times the 5 times the 10 plus 2 times the 10 multiplied by the 2. How much do we get there? 180. We don't even need to one decimal place there. Probably that's why they didn't say that. Okay. So 180 there. 180. The unit for measuring area, it's square centimeter. Some people like saying centimeter squared. It's not centimeter squared. It is squared centimeters, guys. Okay, that is all from me today. 2 hours, here we went. If you reached this far, guys, I'm proud of you. You deserve to pass the test that you're going to write for paper 2. Even if you watched this video for 30 minutes, took a break, another 30 minutes, took a break, another 30 minutes and took a break, up until you finish the 2 hours, I'm proud of you guys. As long as you finish the video, I'm proud of you. So please make sure you go practice heavily. So, like, to be honest, a video this long, there's no way I made it for likes or for views or for subs. This is for you guys. This is for me to help you. People usually don't like videos of 2 hour long sections. So this one is for you guys. Please go study and make sure you ace that test. Okay, see you next year if you're done writing, and all the best. Thank you. Don't forget to like and subscribe, by the way. Thank you.